طيب. Now we want to solve some problems as a practice. In our today class. طيب. Solve the linear system. طيب. We have, this is a linear system and we want to solve that system. The first thing always to solve is to put في augmented form. Augmented form, that is, you know, we have the A and this is the B, like that, where A is the coefficient matrix and B اللي هما values here after the equality, correct? طيب. What is the coefficient matrix? The coefficient matrix في the first part, this part, اللي هما coefficients of the X والY والZ والW. So from the first equation, we will get 1, because here 1, then 1, 1, 1, وهكذا, صح? Z1, وهي, while here 1, 1, 2, 2, so 1, 1, and etc. Everyone, I believe, familiar with this part. So this is the augmented matrix for this system of linear equations. Then after that, what we do? We try to reduce either to the Gaussian or the triangular. But here طبعا triangular لأنه الماتريكس حقتي 3 by 3. هنا is it no 3 by 4, correct? How many? 3 rows and 4 columns. So you cannot reduce it to the triangular form. Anyway, type. We want to reduce it to the echelon form. So quickly give me what you will do. For instance, I'll do at least 2 rows. Type. We want to make, always we start by this is, if this is 1, خلاص. If this was another number, then what I'll do, I'll switch if we have any other row starting with 1. Otherwise, I will divide if لو كانت هنا 2 and some numbers here, so I'll divide over 2. لو ما كان في one of the rows فيهم 1. Okay, if this was 2. I can have fractions sometimes, yes, it may happen, so no problem. But the calculation will be tedious. Okay, طيب, in our example here, so alhamdulillah, this one is 1. So it is the leading one. Okay, so the first task I'll do, make all the others with it in the column. We make them, you know, zeros. Yani this one should be 0 and this one is 0. How we do that? By using the row that has the leading one. So I'm going to use R1. يبقى هيبقى عندي شنو؟ هعمل شنو؟ هعمل R2 first. I'll change R2 to be this element 0. So R2 minus R1. This will make this element easily to be 0. So this is, I'm going to get the matrix. Which matrix I'm going to get? 1. The first, as it is, will stay, correct? This is 1. And then when we're doing the subtraction, 1 minus 1. 1 minus 1 is 0. 1 minus 1 again is 0. And 2 minus 1 is 1. And then 2 minus 1 is 1. And 2 minus 1 is 1, correct? Then after that, we need to make as well this one 0. So I'm changing which row? R3. So the new R3 is equal to the old R3. Type, I want to make this one 0. How I'll make that? By multiplying this, لأنه هنا this 2, and I want it to be 0. So I multiply this one by minus 2 and then add. Okay. يبقى حيكون شنو؟ 1 في minus 2 is minus 2. Minus 2 plus 2 is 0. And then 1 في minus 2 is minus 2. Minus 2 plus 2, again, it is 0, correct? And then 1 في minus 2 minus 2, 3 minus 2 is 1. And then 1 في minus 2 is minus 2. Plus 4 is 2. Correct? And lastly, 1 في minus 2 is minus 2. Minus 2 plus 4 is 2. Yes? So I have 1 and the other 2 elements under it are zeros, and this is my leading one. Now next, what we do, we come to the second row. Yes? But in this case, what, okay, so I come to the second one, which is this one. Where is the leading one? This is the leading one. The first non-zero element is the leading one. Yes, this is my leading one. Okay. Now what we do, the second step, we make other elements with it in the column zeros. That means I want to make this one 0 and I want to make this one as well 0. So how I'll work, how can I proceed? Same way like that. Where is the leading one? This row has the leading one. So I will use it to make this 0 and this 0. Actually, this is 1 and this is 1. So just subtract, and I'm going to change. So R3 minus R2. Correct? This to change R3. To change R1, so R1 minus what R2, and then get the second matrix and etc. So it's clear the steps. We make a revision to how to reduce the echelon form. Let me show you the solution. Okay. I don't know why it does not work. Any idea where is the problem? Yeah. Okay, so when you reach to the echelon form, you will end up by something like that. Now, how I proceed after this? How we proceed? Tell me. How many solutions we will have? How many solutions we have? You can open your mic. Yani you do some steps here, and then at the end you will find that this is the reduced echelon form. Yeah, infinitely many number of solutions. Why? How many leading ones we have? افتح المايك. How many leading ones? 3. Where are they? The first row, first non-zero element, this is the first. Here, the second row, the first non-zero element, this one. The third row, the first non-zero element is that one. So I have how many leading ones? 3. يبقى we have 3 leading ones. How many unknowns? How many unknowns? 4 unknowns. So I have 4 unknowns. يبقى الستيتمنت تحت الرول بتقول شنو؟ When I have the number of leading ones is less than the number of unknowns, يبقى we have infinitely many number of solutions. Correct? طيب, what is the solution? How can I get the solution? طيب, we come to the column that has no leading one. Where is the column that has no leading one? This is the column that has no leading one. Yes? Type. So what is the variable? If this is X and this is Y, this is Z and this is W, okay? Then the column that has no leading one, we let the variable of it, we give it any real number. So we say that let what Y is equal to T. Let Y is equal to T. Okay? Where T is what? T is any real number. 2 minus 7, half, 15, square root of any real number. And then we get our solution depending on that variable. And this is why we say that it is a dependent solution. Okay? So يبقى حيكون عندنا شنو 1 في x plus y, but the y is equal to t, so plus t is equal to, this is 0, this is 0, then is equal to 0, so is equal to 0. This implies your x is equal to minus t. And then from the second, what do we have? 0x plus 0y plus 1 phi z, which is z, is equal to what? Is equal to 0. Then the last one, 0 plus 0 plus 0 plus 1 phi w, that is w, correct, is equal to 1. And don't forget, we have a y بتساوي t. يبقى هنا حيكون عندنا ال y is equal to t. بعد ال y في z, z is equal to 0. And then the w, so the w is equal to 1. يبقى what is the solution? Then this is the solution. A set of vectors minus t in this form, minus t 0, 1, such that t is any real number. So this is the solution. And why it is infinitely many number of solution? Because whenever you change the value of t, you're going to get a new vector. لو خدت t1 هيكون minus 1 1 0 1. لو خدت 2, so minus 2 2 0 1. طيب if he said give me one exact solution, لو قال لي one exact solution, فلنفرض في المسألة and give me an exact solution, how you can get it? كيف حتقدر تجيب ال exact solution? From here, substitute a value for t. For instance, take t ب2. So an exact solution اللي هو S1 حيساوي شنو؟ minus 2, 2, and then 0, and then 1. So this is the exact solution. Clear? Clear? This was the first part, the first chapter, and I believe should be clear for everyone. Any question in this part? في سؤال؟ في سؤال؟ طيب. Now this one. Let A equal to 120A. Find all values of A for which A square is symmetric. طيب. إذا كانت دي الماتريكس A، عايز القيمة بتاعت A اللي بتعمل شنو؟ for which A square is symmetric. طيب. What should I do? What do we mean by symmetric? افتح المايك رد عليه. Answer. Open the mic and answer, please. First, what do we mean by symmetric?
It equals the minus of the matrix.
No. No. The minus? Uh-huh. I'm waiting. What is the meaning of the transpose يا جماعة? We did. Yeah, okay, I can say that, but this is, I can say it in another way. An upper triangular has.
The matrix transport is equal to the same matrix.
Yeah, so that is an A transpose should equal to the A. That means what? If we have, this is a matrix, we knew that immediately if I took, this is the diagonal, it will work like a mirror, correct? So every element, let's say this element, you do like that, should be the same like that one, and etc. For every two elements, يعني A, element Aij should equal to the element Aji. Yes? And if this happened, then you will find this matrix here when you got the same here A, okay? And then you find the transpose of it, okay? Then what will happen? Then you will find that they are the same. They are the same. So this is an A transpose. And this is the matrix A. You will find they are the same. And we knew that this will happen when an Aij في matrix is equal to Aji. That means across the diagonal, okay, images that they are the same, object والimage حقه. Correct? طيب, okay. Let's solve this problem. Okay, how we proceed? How we proceed? نمشي كيف؟ نعمل شنو؟ First, what we do? Find all values of A for which A square is symmetric. A square is symmetric. Type how that means not A is symmetric. The A square, this matrix اللي هي تكون symmetric. Type how we do that? First we will have to find ال A square. يعني دي الماتريكس A square اللي هي A في A, and then you multiply. How we multiply? We multiply a row times the column and then find the answer. الماتريكس من الأول أنا عشان ما أعرف, this is 2 by 2 and this is 2 by 2. First I can multiply them and the resultant it should be a 2 by 2 matrix, correct? طيب, so I know اللي هي الماتريكس الريزلتنت حقتي حتكون شنو؟ 2 by 2. طيب how we find the values? We multiply a row times the column. So 1 في 1 ب 1, correct? Plus 2 في 0 ب 0, so it is 1, correct? And then after that we multiply the other column. So 1 في 2 ب 2 زائد 2 في A ب 2A. So this is going to be 2 plus 2A, correct? And then after that, what? We go to the second row and multiply it. So 0 of 1, 0, plus A في 0 is 0, correct? And then 0 في 2 ب 0 plus A في A ب A square, correct? 0 في 2 ب 0 plus A في A ب A square. طيب دي ال A square. Then we want to see when A square could be a symmetric matrix. For what values of A? What should I do? دي هي الماتريكس A square. What should I do? How you got it? How you got it? جبتها كيف؟ What I do? افتح المايك. How can I find the value of A عشان ما تديني this one من هنا? How can I proceed? We said we do like كده الميرور, correct? There are two ways. So this is the first. That is this one should equal to this. If the matrix is symmetric, then ال AIJ حقها لازم يساوي ال AJI بخلاف الdiagonals. طيب اوكي. So هنا حيكون عندنا شنو؟ This is the element what? This is the element 1 2. This is يعني A1 2 اللي هو بيساوي كم؟ بيساوي 2 plus 2A should equal هأعكس هنا A21. Where is A21? ده the second row, the first column, correct? This is equal to 0. This implies 2 plus 2A should equal to 0. That is 2A should equal to minus 2, correct? And this is divide both by 2 over 2, then over 2. And this is A is equal to minus 1. So this A square will be symmetric only when the A is equal to minus 1. If you want to check that, let's substitute by minus 1 here. So what I'll get? I'll get 1, 2, minus 2, so it is 0. And then here 0, and here minus 1 for minus 1 is 1. And then when you do like that, yeah, this element is equal to this element now. So this is the only case. طيب مثلا let's assume أخذت ال A by 2. Does it هل ممكن it works? No, never. يعني مثلا this is going to be 1, and when A is 2, 2 في 2 by 4, 4 plus 2 is 6, and here 0, and 2 square is 4. So any other value will not make these two elements equal. Will never be equal. Clear? So the only way out is when A is equal to minus 1. This is a way for a solution. طيب can we solve it in another way or no? احنا هنا استعملنا ال AIJ is equal to AJI. How can I proceed in another way? We find the transpose and equate, صح؟ لأنه احنا قلنا شنو؟ قلنا this is your A. طيب this is my A square. طيب نجيب الترانسبوز حقها. What is the transpose? نجيب ال A square transpose. What is it? It is 1 وهنا 2 minus 2A and then 0, and this is A. And we said the matrix will be symmetric if the matrix is equal to its transpose. And he asked me that A square هي اللي تكون symmetric. So this is the A square. Okay, so this is the A square and this is the transpose بتاعها. Okay, يبقى what we have? We have this one. أول حاجة this is 1, this is 1. Okay, this is 2 minus 2A, this is 0. This implies 2 minus 2A should equal to 0, and when you calculate طوالي A is equal to minus 1. Now we come to the second. 0 is equal to 2 minus 2A, but it's the same as this equation where A is minus 1, and this is A and this is A. يبقى this will happen when A is equal to minus 1. Clear? Clear? Any question for now? Or is it clear? Or it's clear? If you have any question in between, please ask. حتى وإحنا شغالين لو عندك سؤال في أي حاجة أسأل. Okay? طيب. We move to the second. let الحاجة دي matrix ولا determinant is equal to 1. If this determinant is 1, find this determinant. Okay, that means I need to use the fact that this one is equal to 1 to find my new determinant. That means I will try to use the determinant operations and try to get at the end this times some constants, and I know, correct? There are, when for operations we have determinant operations and we know the operations, these operations, correct? Type. Okay, now this one I want to reach to what form? To this form times some numbers. Okay, now I will compare. So this row and this row, they are the same, so no need to change this row, correct? Type. Now if I look at this row, what? Okay, already X, Y, Z, it is here. So I need what? I need a row that has U, V, W. Okay, so that means I can change this row. How can I change this row? How can I how can I change this row? عشان يبقى U, V, W. R1 is equal to R1 minus R2. طيب هل الفاليو حقت الديترمينانت if I did this is going to change or will be the same? الرول بتقول شنو theorem the determinant this one and the one I'm going to get the new one when I do this, they are the same. صح؟ الثيورم الستيتمنت بتاعت الثيورم said that if a new matrix is got from the previous one by multiplying a row by a number and then add, so this is we multiply R2 by minus 1 and then we add this 2, correct? So it will not change. Type, what is the new determinant? Okay, خدنا الايكواليتي. What is the new one? It is U, correct? V, because U1 plus X minus X, so it is U. V plus Y minus Y, it is V. W plus Z minus Z, it is W. يبقى my determinant is going to be equal UV, and then here W, and then here X, Y, and then this is Z. Type. Also, I can change this one using this. Why? Because I need only the A or B or C. So how can I get A or B or C? How can I get it? Yes. So I will change R3 and the new R3 is equal to the old one minus this one if I multiply it by 2. لأنه هيبقى 2x, 2y, 2z. So I'll cancel this. So R3 minus 2R2. هيبقى عندي شنو؟ A plus 2x minus 2x by A, correct? B plus 2y minus 2y, so it is B. And then C plus 2z minus 2z, so it is C. Okay, so this value, it's the same as this value. Now I'm looking after this one. Can I reach to this form? Yes. What I'll do, interchange this one and this one. between these two rows. Correct? Okay. طيب يبقى this the all is equal when I switch the new that is going to be equal to A, B, C, and then X, Y, Z, and then U, V, W. Are they equal? No. The all a different حاجة from this, the new, by interchanging. And when we interchange, they differ by a minus sign. Yes? So I put the minus sign. Okay. يبقى شنو؟ This, which is this one, is equal to this determinant, is equal to minus this determinant. But I know the value of this one. It is actually this one. What is the value of this one? It is 1. So this is equal to 1. So 1 في minus 1. So the answer is minus 1. Is it clear? Clear? يبقى عندنا whenever he needs a determinant and he gave me another one, that means I tried to use the determinant operation and to reach to this form. And in between, sometimes I have to multiply by a minus sign or multiply by a number or divide by a number, or they are the same like when we go from here to there. Okay, clear? Now we come to question 2. Determine whether the vector z, this one, is a linear combination of the vectors 1, 2, 3, 0 and y 2, 1, 6, 0. Okay. هل this vector is a linear combination of these? That means هل this vector is equal to C1 times this vector plus C2 times this vector? Yes. هل could I find some constant C1 and C2 such that Z is equal to C1 X plus C2 Y? يبقى my task is to find these constants. Okay, the C's, C1 and C2. And we said if we wrote this one, اللي هو 1, 2, 3, 0 is what is the vector 1, 2, 3, 0, like that. So this one you multiplied by C1 and then the other one you multiplied by C2, correct? اللي هو 2, 1, 6, 0. And this should equal to your vector, which is this one, and that is what? 1, 2, 1, 1. طيب, so if we simplify these two vectors, what you will get? You will get C1 plus 2C2, correct? And then 2C1 plus C2 and etc. Clear? And this one is equal to your vector, which is 1, 2, 1, 1. And we said that we will find that we have a system of linear equations such that this is the first equation is equal to this, because two vectors will be equal if each component is equal to the corresponding one, correct? And this here one should equal to this 2 and etc. So to solve for C1 and C2, we put in the augmented matrix and solve. And no need actually for these steps. We knew and we said that instead of writing all this, what we do? خلاص. Which vector we want to write or to test that it is a linear combination? This one. So this is the B part, correct? So this is my B part. Okay, and this will give me my A part, اللي هو الcoefficient matrix. Okay, so I write that. يبقى هيكون عندي 1 2 3 0 1 2 3 0 and then this is 2 1 6 0 2 1 6 0 and then 1 2 1 1 1 2 1 1. So I'm looking after what? After the C1 and the C2. What we do? Reduce to the echelon form. That is, I'll start by making this one 0 and then this one 0 and try to find the value, solve the system. But I'm telling you, you can proceed like that, correct? But to gain time for me, okay, easily from here, immediately, I will say no solution, that they are not a linear combination. Tell me why. Why? ليه أنا لاحظت الحاجة دي؟ Why I noticed that? Why I noticed that? ليه عرفت الحكاية دي؟ كيف عرفتها سريع؟ Why? Yes. طيب. Yes. أول حاجة from this, the last one. 0, 0, 1. Could it happen? No. يبقى no solution. لأنه 0 عمرها ما بتساوي 1. يبقى no need for any steps. From the last row, R3, since I have 0, 0, 1, okay, I'll have fourth row. So that means this system has no solution. Okay, so that means this one, Z, is not a linear combination of the others. And I'm done. Clear? Clear? يبقى ما كان محتاجة من الأول to reduce to the echelon form ولا 2 و3 لأنه في النهاية حتصل لنفس الحكاية no solution. طيب now the second part. Determine whether S set of vectors, this is the first one, a second, a third, or fourth, is linearly independent set of vectors in R3. طيب هل هم linearly independent ولا لا؟ To determine that لازم to show this. From the beginning I can tell. Yeah, I have. هم ديل elements from where? From R3. From R3 I need come from R3. Okay. Every 3 linearly independent vector, they can span the space. لو لقيت 3 linearly independent خلاص طوالي I can generate the space. يبقى لو كان في واحد fourth حيكون شنو؟ حيكون depend on the others. So لو هم 4 definitely one of them at least one of them depend on the other. لو كانوا 3 independent خلاص they are bases. 4 مستحيل يكونوا independent. Okay, يعني this from this I can find 3. They can be 3 of them independent. They could be 2 independent, and etc. But sure, 100%, all the 4, they cannot be independent. طيب how we proceed؟ عشان ما أشوف dependent or independent. Okay, عادة المفروض أعمل شنو؟ حتى لو ما even if I didn't notice that. Okay, how can I know that the vectors are dependent or independent? Tell me. وحتى لو I notice that, I have to do the steps. Because it's not just true or false like in the quiz. طيب كيف نثبت انه دائما ال vectors are dependent or independent? What is the theorem? What is the way? افتح المايك وكلموني. I'm waiting for an answer. Okay. What's the first? Yes. To find the determinant and is it 0 ولا لا? Can I use it here? My question. Can I use the first theorem here اللي هو find the determinant؟ طبعا عشان تشوف dependent or independent. To remind you, we can find the determinant. Put the vectors في حالة بتاعة determinant and evaluate. If the determinant is equal to 0, that implies they are dependent. Correct? طبعا definitely العكس. إذا كانوا not equal to 0 معناها independent. طيب, can I use this here? can I use this way here in this case ولا لا؟ Can I use the way here or no? I'm asking. طيب خليني اكتبها. لو عايزه اجيب الديترمينانت كانت حيكون شكلها شنو؟ 1 0 minus 1 2 1 0 3 1 minus 1 1 1 1. طيب. Can I use this theorem here or no? ممكن استعمل الطريقة دي واوجد الديترمينانت؟ No. Why? Why? ليه لا ما ممكن؟ No. No. ما عشان very long. Because this is not a square matrix. 1 2 3 1 2 3 4. A determinant is defined for what? For a square matrix, but this is not a square matrix. This is 3 times 4. So I cannot evaluate it. I cannot use this method. واضح؟ طيب طيب okay. Now what is the other theorem? انا معي طالب واحد شغال، الباقيين ياخدوا كلهم اصفار يعني ولا شنو؟ كانوا 2 وهسه بقى 1. اها. What is the other? How can I prove that they are linearly independent? الأول لقيناه ما نافع الطريقة الأولى. طيب what is the second one? What is the second one? Find the C's. طيب how? What's the statement? طيب we assume that yes that C1 في X1 زائد اللي هو ده الفيكتور X1 زائد C2 في X2 زائد C3 في X3 زائد C4 في X4 is equal to 0. And now my task will be to find the C's, solve يكون عندي system of linear equations, correct? And actually it is homogeneous system ليه؟ لأنه all the elements here are zeros, and try to what? To reduce it to the echelon form and calculate. يعني هنحطه في augmented matrix, reduce it to the echelon form and or triangular form to find the values of the C's. C1 C2 C3 C4. طيب الستيتمنت بتاعت الثيورم شنو؟ السيز if all are zeros then what? This imply what? لو طلعوا كلهم زيرو. Independent, yeah. وطبعا العكس إذا طلع عندهم values they are dependent. One of them can find it in terms of the others. Okay. Okay, يبقى we do like that. Now if you reduce to the echelon form, so you do this. and احنا قلنا this is هيكون شنو؟ كله ال A part. What is the B part? ال B part هو 0. So like that. Try to reduce to the echelon form so you reach here. طيب if this is the system, now do I have a solution or no? Do I have a solution? هل في حل؟ Infinitely many number of solutions. Why? Because the number of leading one is what? So this is the first leading one. نجي للfirst row. نجي للsecond row. This is the leading one. نجي للthird row. هل في leading one؟ لا. All they are zeros. يبقى it has no leading one. يبقى عندي كم leading one؟ 2 leading one. وعندي كم column؟ 1 2 3 4 column. يبقى عندي 2 leading ones. Okay, and عندي 4 unknown. A number of leading one is less than the number of unknown. يبقى infinitely many number of solutions, correct? طيب, which columns has no leading one? Which column has no leading one? This column and this column. By the way, here in this example, طوالي, since there is infinitely many number of solutions, يبقى the system is linearly شنو? What? Dependent ولا independent? Dependent. The system is dependent. وخلاص finished المسألة. But if he said find the constant, okay, or he said find one vector, okay, in terms of the others, one vector that is a linear combination of the others, I have to continue the solution. But in this example, we are done. It is finished. It is finished in this example, okay? طيب. طيب, if I want to continue and find the C's, let's do that. لو عايزة أوجد السيز، يلا. How can I find them? How many column has no leading one? You said 2. Okay, this was corresponding to X, and this is Y, and this is the Z, and this is the W. We assume any real number to Z. Let's take it مثلا R. And this one, let's take it S. Okay, يعني let Z is equal to some R. R ماله is a real number. And W equal to some other real number. S belong to real number. And then we get our solution now. It depends on 2 variables, على ال R وعلى ال S. So how we proceed? This implies 1 في X بX. Correct? If you want to go like that. No, I have to reduce to the echelon form. قبل ما أمشي كده, I have to reduce to the echelon form. Okay, to reduce to the echelon form. هل this reach to the echelon form? No. What we should make? We should make this element here 0. Where is the leading one? Here. So that means I'm going to use this row here. يبقى حيكون عندي شنو when we reduce to the echelon form? What I'll have. طبعا this one I cannot reach to the triangular form. عشان كده لازم أوصلها للreduce echelon form. طيب يبقى حيكون عندي شنو؟ I'm going to use the second row to change the first row. يعني حيكون عندي R1, I'll change it, which is minus 2 R2. Yeah. So what is the new determinant? It is 1. Because 1 minus 0 is 1. 2 minus 2 is 0. And ده هضربه في minus 2. Minus 2. 3 minus 2 is 1. And then 1 في minus 2 is minus 2. And then 1 minus 2 is minus 1. And here we do the same. But these are zeros, so they stay as 0. The second one as it is, so 0, 1, 1, 1. And here 0. And the last 0, 0, 0, 0, and then 0. Okay, so now what are the leading ones? Yeah, this is the leading one, the first for the first row. For the second row, this is the leading one, and the up or above it and below it are zeros. Okay, now we proceed. We let the Z بتساوي ال R. هنا دي Z بتساوي ال R وال W دي بتساوي ال R وال W قلنا بتساوي ال S. And now we can find our solution. So what do we have? We have, this is corresponding to the X and this one corresponding to the Y. So 1 في X is X plus 0 Y, okay, plus 1 في Z بZ اللي هي Z equal to R, so plus R plus what? Minus, sorry, 1 في W minus W, but the W is equal to S, so minus S is equal to 0. And from this, that means the X is equal to this real number R minus S. And then from the second row, what do we have? We have 1 في Y by Y plus 1 Z was Z هي by R, so plus R 1 في W by W, but the W is equal to S, so plus S is equal to 0. That is the Y is equal to what? Is equal to R plus S. And then this is the X, this is the Y, and then this is the Z is equal to what? Z is R. And what is the W? W is equal to S. Okay, so this is a set of solution, okay, such that set of vectors such that R or S belong to a real number. So if you took any value for R, even if they are the same, خلاص يعني I can take مثلا ال R by 1 وال S by 2, and then you substitute here, so you'll get the first solution. Then change, you'll get a second. So what can I put 1 1? Yes. Clear? So it's clear infinitely many number of solutions. But I don't need this step here. خلاص, immediately when I reach here, since there are infinitely many solutions, that means there is a solution. طيب there is a solution if they are linearly dependent. وخلاص, finished. Clear? واضح؟ واضح؟ طيب. Now, determine whether W is equal a set of vectors x, y, z such that the x is equal to z square is a subspace of R cube, of R3. How we proceed? How we proceed? How we can show that a space is a subspace of R3? كيف نعرف إنه a subspace or no? What is the theorem? We have to prove what? 3 things. Yeah, if you prove that it is a linear combination, then you're done. Linear combination of شنو؟ أو يعني معناها span of some vectors. خلاص؟ span يعني معناها linear combination of a vector and another مثلا vector and another وهكذا. Yes? Or what? Or else what you can do? This is one way. طيب the second way. واحد, to prove 3 things. 1, it is not empty. Correct? The second, that any 2 vectors, if we took a vector x1 and we add it to x2, it should be closed. This should belong to your space W, closed under addition, and closed under scalar multiplication. That is constant times any vector, arbitrary vector, x1. Also, the answer should belong to W. If x1 belongs to W, then Cx1 should belong to W. Yes? طيب. يبقى I have to test. First, let's see how our vectors look like. How they look like. اللي هم الفيكتورز حقتنا. مثلا one of the vectors is what? Is x, y, z. X, y, z. But this vector, there is a certain condition for x. this x is equal to what? Is equal to z square. يبقى my vector will look like this is z square and this is y and this is z. Give me an example for a vector in W. اديني أي مثال. What? Because it is from R3, so I'm going to substitute with real numbers. For instance, if I take ZB2, so an example, this is for you, just to understand the thing, عشان تكون عارف شكل الفيكتورز ديل. طيب كexample, give me one. If we take a ZB2, 2 في 2 ب4, حتى هنا 2. What about the y? Y can be any value. ممكن اخذ 0, yes. I can take 1, yes. I can take -1. So, but whatever you take here, this should be the square of it. This is how my vectors will look like. طيب, now we want to see that it is a subspace or no. Okay, here, if you want to proceed like that, what should I do?
The vector plus itself.
طيب اللي راح يكون شكلهم كيف يعني؟ This one, can I write it? Can I write it? يعني مثلا ممكن يكون Z في ما ممكن صح؟ لأن ده حيكون هنا Z square. Here, can I write here 1 مثلا 0 1? No, صح? Because this is not a Z square. So I cannot use this way to find صح؟ هل في طريقة؟ اكتب الفيكتور ده كيف؟ طيب this is plus. طبعا حتة y I can write here 0 1 0. طيب okay. Now what about this one? I cannot write it صح؟ Z square. لو خطيت Z square هنا هتبقى Z square and هي Z square. Correct? So this is Z square. It's not Z. Or I can do Z square 1 0 0 plus Z what 0 0 1. Okay, so this is a constant and this is another constant and this is another constant, correct? So it can be expanded by these three. They are linearly independent. When it is the same, I don't advise you go like that because this is Z square and this is Z. So we go using this way. Okay. Type. We knew that our vector will look like Z square Y Z. Type first, is it not empty? Yes, it is not empty. واحد, not empty. لأنه consist, if we took a Z ب0 والY ب0, then it شنو 0 0 0 ماله belong to W. So not empty. طيب, the second thing. We should take two vectors and check the answer after adding them. Does it belong to W ولا لا؟ هاخد two. For instance, I'll take Z1 square Y1 Z1. So this is the first vector. And take another vector اللي هو مثلا Z2 square Y2 and then Z2. Yes. Type. Also, this one belongs to W. This is how my elements look like. Type. Now, what when I add them? This is equal to Z1 square plus Z2 square. And this one Y1 plus Y2. And this one Z1 plus Z2. طيب هل this one belong to W or no? Tell me. هل it belongs to W ولا لا؟ No. Why? ليه العنصر ده ما في W؟ شوف العناصر هنا. So this is any real number. ما عندي فيه مشكلة. But في شرط. There is one condition. Whatever I put here, this should be the square of it. So whatever I put here, هنا أنا I put شنو Z1 plus Z2. هل this one is the square of it؟ هل Z1 plus Z2 square بتساوي Z1 square plus Z2 square? Is it true؟ هل ده صح؟ Is it true؟ No. Why? Because this one بيساوي Z1 فك المربع Z1 square أول تربيع زائد 2 الأول في الثاني twice the first time the second Z1 Z2 correct plus Z2 square يعني المفروض this one يكون الأنسر which is here. So but here it is this يبقى and this one not equal to Z1 square plus Z2 square. ليه؟ لأنه في difference of this number. يبقى no. يبقى it is not a subspace of R3 because what? Because it's not closed. You can go like that. And even if you want, you can prove this one as well, using this one as well. Clear? So from here, we prove that it is not a subspace. Also, I can prove that it is not a subspace. خلاص كده you are done. If you want to use this method, let's use this method and check this it will work ولا لا. طيب, I take this element and now I multiply times the C to check that does it belong to W or no. طيب, هيكون عندي شنو الناتج؟ say Z1 square Y1 CY1 and then CZ1. What do you think? Does this one belong to W or no? It belongs to W or no? Tell me. Does it belong to W? I'm asking, does it belong to W or no? What should I test? The condition. This is Z and this is Z square. Type. This is Z, now الvalue حقتي. This should be the square of this. Type. What is the square of C1? Z. Type C1 Z1 square. This is he sees this is equal to C square Z1 square. Type. هل هي the same like this? No. This is C square while this is C. يبقى this is does not belong to W. يبقى this one, this condition is not working. يبقى it is not a subspace. يبقى you can prove it like this or you can prove it like that. Both, they will show you that it is not a subspace. So you can choose any one of them. Okay, we'll stop here. Okay, and next class we will continue doing some other problems. Okay, in the coming week. Okay.